And now we have another section which is wave for infinite length. For the wave of infinite length, we use D'Alembert methods. We use D'Alembert method for solving a wave for infinite length. We say if we have this partial differential equation, this partial differential equation is the wave equation. It's wave equation. As x is from minus infinity to infinity, that means it is for infinite length. So if you have given the initial conditions to be u of x0 to be this, to be f of x, and that means the function that you will be given for u of x0 is f of x, and u sub t of x0 is g of x. That's g of x. You should identify what's f of x and what's g of x. Okay, for u is f of x, and for u sub t is g of x. Okay, we say the solution for the above problem is can be written like this. So here, using D'Alembert method, we just use this formula. If we just know how to identify f of x and g of x, that's all. That's all. Okay. Here, this is the wave equation. The wave this wave equation can be written as this also. Say partial square root of u by partial t squared minus c squared. If you move this to the other side, we get minus c squared partial squared u by partial t squared. Sorry, partial x squared. It could be written like this or down. Okay. Here we have an example. We have given the wave equation. We have given the wave equation. So here we have t squared. It's the wave equation. We have given u of x0 with sine pi x. If you compare with the above one, let's see. In the equation, in the partial differential equation, here in the above one, we have c squared minus c squared. That means c here, c squared here is 1. C squared here is 1. So c is 1. C is 1. And u of x0, as you see here, we said that u of x0 is f of x. That means f of x is sine pi x. And u sub t of x0 is g. This is u sub t. It's the same as to say u sub t of x0 equals 0.5. That means g of x equals 0.5. We have f of x, g of x, and c. Now we apply this rule. We just put f of x, g of x, and c into the above formula. We say here c equals 1. F of x, we should identify these three things. F of x is sine pi x, and g of x is 0.5. This 0.5. Now we have these three things, and then we can put these three functions into the formula, into the above formula. Yeah, we have f of x plus ct. That means x plus 1t. Here we replace each x by x plus 1t in the function of f. Let's find these also. F of x plus ct equals to f of x plus t, and x plus t is sine x plus t pi, and sine x plus t pi equals sine of x plus t times pi. And for g of s equals, here we just replace, if we have x in the function of g, we just replace by s, and here we have no s, no x, so we say it's 0.5. Okay, that's all. Now we replace f of x plus ct by sine of x plus t pi, and you replace g of s by 0.5 into the above formula. We say u of xt equals a half of what? F of x plus ct. X plus ct. So it's minus, okay? For the negative also. F of x minus ct, it is sine x minus t times pi. We say it equals a half of f of what? F of x plus ct. X plus ct, f of x plus ct is sine of x plus t times pi. Okay? Then plus f of x minus ct, x minus f of x minus ct is sine x minus t pi. Is sine x minus t pi. And then we have plus 1 over 2c. C is 1. Or still 2. Integration. From x minus ct, as c is 1, we say x minus t to x plus t. For what? For g of s. G of s is 0.5. ds. Now we are going to find that integration. We are going to find this integration. First, let's write down the bracket the same. So u of xt equals a half of sine x plus t times pi plus sine x minus t times pi. It equals a half of integration of 0.5 ds is 0.5 s from x minus t to x plus t. That's one. Now we first replace as by x plus t, and then you replace by x minus t, and you get u of xt equals a half of sine x plus t pi plus sine x minus t pi plus plus a half of 0.5 x minus t, this is x plus c, minus 0.5 of x minus t. And so this bracket becomes 1t. It becomes 1t. So you get only half of t. This one becomes a half of t. So you get u of xt equals a half of sine n t. So sine x plus t pi plus sine x minus t pi plus half of t. This is u of xt. So now we can use the trigonometric identities to expand these two sine functions. So you say u of xt equals a half. Here, which is sine of x plus t equals sine x cosine t plus cosine x sine t. It equals sine x pi cosine t pi t plus cosine x pi times sine pi t Then for the negative 1, it's the same. It's plus sine x pi cosine pi t minus is cosine x pi sine pi t o plus a half of t. Okay, and here we have similar terms. You have cosine x pi minus cosine x pi sine pi t with cosine x pi sine pi t. These are cancel out because both are the same in different signs. So you get u of xt equals a half of these two are the same with the same sign, and you say it equals 2 sine pi x cosine pi t plus a half of t. These two are cancelled out. These two, we get sine pi x cosine pi t plus half of t. This is the solution for that partial differential equation by using the D'Alembert methods. If you are asked to use the D'Alembert method, you can just use that formula. You can just use this formula and identify f of x and g of x, also c. That's all that you should know. That's all. So it's the solution. This is the solution. This is u of xt, which is the final results. Now we have another example that we should show that the solution for this differential equation, for this partial differential equation, equals sine 2x cosine 2t sine 2x cosine 2t plus sine x sine t. We should find the solution, and then we must get the same result as it's given. Okay, here this is f and this is g. Okay, that's f and that's g, and c here is 1. C here is the coefficient of partial square root of u divided by partial x squared. That's 1. And now we say we use the same as we did before. We say f of x equals sine 2x, and g of x equals sine x. And also c equals 1. We say u of xt, you should know this formula. U of xt equals 1 over 2 multiplying by f of x plus, look, f of x plus ct, f of x plus ct, x plus ct. C is 1. Okay, that means f of plus t plus f of x minus ct, which is f of x plus t, plus what? Plus the integration 1 over 2c, the integration of g of s from x minus ct to x plus ct, plus the integration from x minus ct, which is x minus t, since t c is 1, to x plus ct, which is x plus t. For what? For g of s ds. But in front of the integration, we have 1 over 2c. C is 1, so it's 1 over 2. Now we're going to put f of x plus t, f of x minus t, and also g of s here to get the solution. We say f of x is sine 2x. So f of x plus t equals sine 2 times x plus t. And f of x minus t equals sine 2 times x minus t. F of g of s is sine s. That's all. Here, we say u of xt equals a half of f of x plus t, which is sine 2 times x plus t. Plus f of x minus t, which is sine 2 times x minus t. Okay, then we cross the bracket, and then we have 1 over 2 the integration of from x minus t to x plus t for what? For g of s. G of s here is sine s ds. Now we take that integration. We take that integration. We get u of xt equals u of xt equals a half of sine 2 times x plus t plus sine 2 times x minus t plus a half of the integration for sine. The integration of sine is minus cosine s from x minus t to x plus t. Now we replace s first by x plus t, then by x minus t, and you get u of xt equals a half of we write down the bracket the same, sine 2x plus t. Let me write down as sine 2x plus sine 2t. 2x plus 2t. We can multiply that 2 into the bracket. We get 2x plus 2t plus sine 2x minus 2t plus a half minus cosine. Let me bring this in the sign out of the bracket. We get minus a half cosine x plus t minus cosine x minus t. Now we are going to expand these cosine of the sum of these two functions and the difference of those functions. Here we say sine of 2x plus 2t equals a half. For the sine, we say this sine cosine, sine the first one, then cosine the first one, which is sine 2x cosine 2t plus cosine 2x sine 2t. Then for this one, we get sine 2x cosine 2t minus cosine 2x sine 2t. This is that bracket. We just expand sine 2x plus 2t and also sine 2x minus 2t. And then we're going to expand this one also. That's minus a half of cosine. For the cosine function, it's different from sine. We say it is for cosine x plus t, we say it equals sine x sine t, minus cosine x cosine t. No, sorry, it is cosine x plus t is cosine x times cosine t minus sine x times sine t. It is cosine x cosine t, plus is minus. If it is positive, it becomes negative, and if we have the difference of two angles, it becomes positive. Minus sine x sine t, and here we have a negative sign. Cosine x minus t is cosine x cosine t plus sine x sine t. sine x sine t. So now we are going to try to simplify this. Let's simplify this. As you see here, this bracket with this bracket are going to cancel out. So you get 2 times sine 2x cosine 2x 2t. We get 2. Look, this one with this one is going to be 2 times sine 2x cosine 2t, and with this one, with this 2 are going to cancel out. We get u of xt equals sine 2x cosine 2t. And then in the next bracket here, if we enter this negative sign into this bracket, this with this will cancel out. And here we get minus sine x sine t, and here also you get minus sine x sine t. That means you get minus 2 sine x sine t. With this minus a half, with cancel all cancel out, and you get sine x sine t. So you get sine 2x cosine 2t plus sine x sine t. And let's compare with the given solution. As you see, we get the same result as given above. So that means we showed that the solution for this differential, for this partial differential equation is given by this one, this formula. Okay, so that's all. How it's how to use the D'Alembert method for solving wave equations.